Okay, first question here. We have differentiate the following function using first principles. Now, always with first principles, what that means is the end product we want, I'll write it in red, is going to be the limit as h approaches 0 of f of x plus h minus f of x all divided by h. So that's what we want to end up with. And to do that, we always want to do it step by step. So first thing we get, what is f of x plus h? F of x plus h, just fill in x plus h for x up here, okay? So that's going to be 2 times x plus h squared minus 8 times x plus h plus 4. Then I'm going to multiply this bracket out. So it's going to be 2 times x squared plus 2xh plus h squared. That's using the fast method. Then we have minus 8x minus 8h plus 4, like that. And then we can multiply this bracket out. So we get 2x squared plus 4xh plus 2h squared minus 8x minus 8h plus 4. Okay, so that's f of x plus h. Then for step 2, we want to do f of x plus h minus f of x. So now that's going to equal this whole thing up here. Just imagine that's written down there again. But we want to minus f of x, just f of x. So that's going to be minus 2x squared minus 8x plus 4, like that. So we're going to have a minus here, minus 2x squared. That's going to cancel with the positive 2x squared up here. So they're going to cancel. Minus times a minus is going to give us a plus. So we have a plus 8x here. That'll cancel with the minus 8x up there. And then we have the minus 4 because it's a minus and a plus. So minus 4, that's going to cancel with the plus 4 up here. So what we're left with for f of x plus h minus f of x is 4xh plus 2h squared minus 8h. Then, third step, we do f of x plus h minus f of x, which is what we just got, all divided by h. So basically just divide this guy here by h. So the 4x, the h is going to go away because we're dividing by h. Then we're going to have a 2h here because this is h squared. And then we're going to have the minus 8 because that h is going to go away as well. Then, final step, we take the limit as h approaches 0 of this thing up here. So for leaving cert's sake, for the limit as h approaches 0, just fill in 0. Don't think about it too much. You can't do this though if you're dividing by h, because you can never divide by 0. So if you have a h on the bottom of a fraction, let's say, you can never fill in 0. And you've probably gone wrong if you have a 0 at the bottom of the fraction, if you're doing first principles anyway. But here, we can just do 4x plus 2 times 0 minus 8. So that's going to be 4x minus 8 is our final answer. And if we look at the original question, if we just differentiate this using our normal method, we're going to have 2 times 2 is going to give us 4, and then we're just going to have x to the power of 1 because it's 2 minus 1, then minus 8 because that x is going to go away. So you can check your answer is correct by just doing that really quickly. But yeah, that's the answer. Next question, we're just differentiating the following functions. So 3x to the power of 7, differentiate that. It's going to be 7 times 3x to the power of 6 because it's 7 minus 1. All right, 7 minus 1 up here. Plus, we're bringing down the 5. It's going to be 5 times 5x to the power of 5 minus 1. Plus 4 times 9x to the power of 4 minus 1. Plus 0, because this guy has no x. This guy has no x next to him. So that's just a constant. I'll write it here. Constant. A constant, they always call a constant. It's just a regular number. It's just a number without an x. Just any number you like. And remember, if you differentiate a constant, you get 0. And in each of these cases, all I've done is I brought the power to the front and taken 1 off it. So all we're going to have is 21 x to the power of 6 plus 25 x to the power of 4 plus 36 x to the power of 3. So that's the first function differentiated. Then we're going to have f of x is x cubed cos 3x. Now, this looks tricky. It's not. We're going to have this guy here is u. We're going to have this guy here is v. So we have a u by v. So if you have d over dx of u times v, it's going to be u dv dx plus v du dx. Basically, leave the first guy, differentiate the second guy, then you're going to be differentiating the first guy, leave the second guy. So I'll call here f prime of x is equal to, so I'm going to leave the first guy, x cubed, then I'm differentiating cos of 3x. So the derivative of cos is going to be minus sine of 3x. But remember, it's a 3x inside here. So then I also have to differentiate the 3x. So that's going to give me 3 left over here. And then I'm going to add, we're going to differentiate the first guy now. So it's going to be 3x squared, take 1 off the power, times the original guy, cos 3x. Then simplifying that, that's going to be 3, or it's going to be minus 3x cubed sine of 3x plus 3x squared cos of 3x. The trickiest part there was this part here, where we're differentiating cos of 3x. Just remember, you have to differentiate the function first, and then you have to differentiate what's inside of it. It's the same if you were differentiating sine or tan or log, we'll say. You have to differentiate what's in the bracket as well at the end. Then we have f of x equals x squared plus 1 over 3x minus 5. This is now a u over v. So up here, we're going to have u. Down here, we're going to have v. And remember, the rule for this is going to be d over dx of u over v is equal to v du dx minus u dv dx all over v squared. So now just fill in. So what's v? So I'm going to say f prime of x. V is just what's on the bottom. So it's going to be 3x minus 5 times du dx. So the derivative of u up here. So that's going to be 2x. And then the 1, when we differentiate it, is just going to become 0. So that's the first part. Then minus u. U is just x squared plus 1. dv dx. So we're differentiating the bottom guy now by x. So that's just going to be 3 because the minus 5 goes away. All divided by v squared. Just 3x minus 5 all squared. Let's simplify that. 3x times 2x is going to be 6x squared. Then we're going to get a minus 10x. Then multiplying these guys, we're going to get a minus 3x squared minus 3, all divided by 3x minus 5 all squared. So now we have the x squared and the minus 3x squared, or the 6x squared, I should say. So that's going to give us 3x squared minus 10x minus 3, all divided by 3x minus 5 all squared. So that's that one done. Remember, all these rules are in your log tables, and the most important thing is just remember, are we multiplying them? Are they dividing? Is it going to be the chain rule? Just write out what u is, write out what v is, and do it step by step, and you can never get it wrong, basically. Okay. Now, we have a graph. We have f of x is 3x cubed minus 2x squared plus x plus 4. Find the derivative of the function at x equals 0. So first thing we're going to do is get the derivative. So differentiating this, we get f prime of x is equal to 3x squared minus 4x plus 1. Because remember, just bring down the power, take 1 off it for each case. And then we want to find it at x equals 0. So f prime of 0, we're just going to fill in 0 for x. 3 times 0 squared minus 4 times 0 plus 1. So that's equal to 1. That means that the derivative of the function at x equals 0 is just 1. So the slope of the function at x equals 0 is 1. So like imagine if we go up here, it's going to look something like this. Or something like this. The slope right at this point here is going to be 1. Then we said, find the equation of the tangent line at this point. So we have the slope, m is equal to 1, and we have the point, p is, well, x is equal to 0 we were given. And what's f of 0? F of 0, if we just fill 0 into this equation, we're left with 4. So this point here that I just wrote over, you can see, actually, no, I should rub that out so you can see that. Yeah, it's at the point 4, 0, 4. So we have the point, we have the slope. Now all we're going to do, y minus y1 is going to be y minus 4 is equal to m, 1 times x minus 0. So that's going to give you y minus 4 is equal to x, or y is equal to x plus 4. So that's the equation of the line. You can write it whichever way you like, but that's how I'm going to leave it. So for part 3 of this question, we want to find the extremal points and determine whether they are maxima or minima. So extremal points, its derivative equals to 0. So what's the derivative? It's 3x squared minus 4x plus 1. So we want to get this equal to 0. How are we going to do that? we're going to use our quadratic factorization, or you can use minus b formula. I'm going to try it like this. So it's going to be 3 times 1 is 3, 1 times 1 is 1. And if I make dash negative and that positive, no, they both have to be negative to get me a minus 4 here. So I can do, a 3x minus 1 times x minus 1. And just to verify that, 3x times x is 3x squared. 3x times minus 1 is minus 3x. And then we're going to get a minus 4x. And that's going to give me the plus 1 up there. Perfect. So this is equal to 0. That means that 3x minus 1 is equal to 0. So x would have to be 1 over 3. Or x minus 1 is equal to 0. So x would have to be 1. So these are our x values. So if we look at this graph, you see the extremal points are going to be this guy here and this guy up here, where the slope is 0. And we just got the x values. We can already see x equals 1 is around there. And 1 over 3 is somewhere around there. Perfect. Now, we want to determine whether they are maxima or minima. Well, first of all, we have to get the y values. So we have to fill these into the function. So we're going to get f of 1 over 3 is equal to, just fill 1 over 3 into the function here. So 1 over 3 to the power of 3 minus 2 times 1 over 9 plus 1 over 3 plus 4. That is 112 over 27. All right, Paul, I'm going to fill both of these in and make sure they're right. F of 1 then is just easy enough. That's going to be 1 minus 2 plus 1 plus 4 is 4. All right, Paul, cut out where I was just calculating there. So, okay, after we got the two x values, then when we fill these into the original function, we get 112 over 27 and f of 1 is 4. So our extremal points are 1 over 3, 112 over 27, and I'll draw it over here, 1, 4. And if we look at our graph roughly, they are kind of thereabouts. You can kind of see them anyway. But then we want to determine whether they are maxima or minima. And obviously we could see that with the graph that this guy here is going to be the maximum and this guy here on the right is going to be the minimum. But we can show that using differentiation as well. So I'm going to rub this out temporarily. And I'm going to show you. Using differentiation, we're going to take the second derivative of the function. So f prime prime of x. I'm going to differentiate this guy here. It's going to be 6x minus 4. Now, let's plug in our values. If I plug in 1 over 3, f prime prime of 1 over 3, that's going to be 6 times 1 over 3 minus 4. 6 times 1 over 3 is going to be 2 minus 4, which is minus 2, which is less than 0. That means, because it's less than 0, this guy here is going to be a maximum. Which, again, when we looked at our graph, x equals 1 over 3, that's going to correspond to this point here, which is the maximum. Locally, you should say. It's between some things, because you can see, like, obviously the line goes up, but it's like the bumps are kind of what they're referring to as the maximum or minimum. And then we're going to do the same for the other guy. I'll rub it out now. So now if I do f prime prime of 1, that's just going to be 6 minus 4, which is equal to 2, which is greater than 0. So that is a minimum. Boom, done. Then the last part, find the point of inflection of the function. We're going to actually use our second derivative here, but I'm going to rub this all out, and I'll do that from scratch. Now, to get the point of inflection of the graph, remember, point of inflection, POI, is equal to, well, not really equal to. What we want to do for it is f prime prime of x equals to 0. And we got f prime prime of x was 6x minus 4, I think. I'll verify that. Yeah, 6x minus 4. So that's equal to 0. That means the 6x must equal 4. And that means x must equal 4 over 6. And that's equal to 2 over 3. So then we fill that into the graph to get our point of inflection, because we have to get the y value as well. F of 2 over 3. Put that into the calculator. And when you plug that into your calculator, you should get 110 over 27. So the point of inflection, POI, is x is 2 over 3, y is 110 over 27, like that. Boom, done. This question here is a rate equation. We have the volume of a sphere increases at a rate of 300 centimeters cubed per second. So immediately, I'm going to write dv, volume, and then it's per second. So we know it's dv dt is equal to 300 centimeters cubed per second. Now, find the rate at which the radius of the sphere is increasing with respect to time. So we want dr over dt. And it's given us, we want it when r is equal to 18. So remember, when we're doing this, we do want equals have times need. So we want dr dt. We have dv dt. So what do we need? Well, we want a dt on the bottom, which we have, and we want a dr on top. So we'll put the dr here. But that means we have to get rid of this dv. So we'll put a dv down here such that if they will cancel when we multiply that. So now we need dr dv. Okay? But what is the volume of a sphere? Volume is 4 over 3 pi r cubed. So that means dv dr, if we differentiate the volume with respect to radius, we're going to get 4 pi r squared. That means that dr over dv is equal to 1 over 4 pi r squared, like that. And now we're saying r is 18. So now we can do dr over dt is equal to what we already had. We had the 300 centimeters cubed per second. That's dv dt. And we're multiplying that by 1 over 4 pi times 18 squared. And when we put that into our calculator, we get 300 divided by 4 pi times 18 squared. We're going to get 0.07. Now, what units? It's going to be centimeters per second. Because the radius is in centimeters, because we already had the volume. The volume was centimeters cubed. So the radius is going to be centimeters. And the unit for time is just seconds. So it's going to be 0.07 centimeters cubed per second. That's the rate at which the radius is increasing when it's equal to 18 centimeters. The key there is just want equals have times need. Always write it out. What you have, what you want, what you need. And then normally when you have what you need, you're probably going to be using a formula from the log tables, whether it's the volume, surface area, whatever. And then you're going to have to mess around with it to get what you actually need. Now, finally, integration. Solve the following integrals. First guy, I'll do it down here. So we have the integral of 3x squared minus 6x plus 4 dx. Well, all this is opposite of differentiation. So this time, instead of taking one off the power, we're going to add one to the power, and we're going to divide by the new power. So that's going to be 3x cubed divided by 3 minus 6x squared over 2 plus 4x plus c. This integral does not have bounds. There's nothing on either side. Like this guy has bound 0 and pi. If it has no bounds, you have to put in the plus c. You will literally lose a mark for no reason if you don't put in the plus c. That's going to be x cubed minus 4. No, not minus 4. Minus 3 x squared plus 4x plus c. So that's the answer to the first integral. Then the next guy, slight bit trickier. We have the integral 0 to pi of 12 sine of 3x. Well, immediately, just to make it easier, we can take the 12 outside. So we can do 12 times the integral of 0 to pi of sine of 3x. Now, in red here, I'll write, if we were to differentiate the sine of 3x, we know the derivative of sine is cosine of 3x, but we would then have to multiply by the bracket here, the 3x, the derivative of what's in the bracket, I should say. So that's going to be a 3 cos 3x, will be the derivative there. But we're integrating this time. So what we're going to have is 12 times, instead of differentiating, we're integrating. So we're going to be dividing by 3. And if we go the other way, differentiating sine, we get cos. If we integrate sine, we get minus cos of 3x divided by 3, like that, from 0 to pi. And if you ever want to check, do. So you can differentiate the top line here, the minus cos 3x. When you differentiate cos, you get minus sine. But then you're also going to get the 3 outside, which will cancel down here with the 3 down here. So it works out. Just if you ever want to, check it. That's equal to 12 times. Now we're going to fill in the bounds. So we always fill in the top bound first. So it's minus cos of 3 pi, I should say. 3 pi divided by 3 minus, then we're filling in the bottom bound. It's going to be minus cos of 0 divided by 3. Now just fill that into your calculator and you should get, what, 12 times cos of 3 pi, 1 over 3, minus the cosine of 0 is 1. That's going to be plus 1 over 3. So when you fill this into your calculator, you should get 12 times 1 over 3 times 1 over 3. Important step here, make sure your calculator is in radians mode. 0 and pi, they're both in radians. If they gave you, they might specify like if it was like 0 to, I don't know, 90 or 180 degrees. If it gives you bounds like this, they're radians. So when you fill that into your calculator, you should get that the final answer is 8. So that's that one done. There's no plus C for that guy because they have bounds. So we're not putting in the plus C. You need to put in a plus C though for the other guy.